In the real world, it is often costly and time-consuming to fully train robotic policies. While training in simulation is a solution, policy trained in sim often fail when transferred to the real world due to the reality gap. Domain randomization is a well-known approach to tackle this problem. However, it requires prior knowledge and engineering to determine just how much to randomize system parameters in order to learn a policy that is both robust to sim-to-real transfer while also not being too conservative. In this work, we propose a method for automatically tuning system parameters, both visual and dynamics, to match the real world, thus iteratively closing the reality gap. Our approach does not require instrumentation of the real world to collect state or reward information, allowing us to rely only on pixel-based observations of the real world. As a result, we are able to adapt our simulator using occasional observations in the real world during training. At a high level, our method interleaves training a control policy for the task with training a search parameter model that identifies whether the current system parameters are too high or too low. We then periodically update the simulator using the search parameter model with a small amount of real-world data. We demonstrate our method on a rope peg and hold task where we update system parameters such as rope length, peg mass, and appearance of the seam. While domain randomization was not sufficient for successful transfer, here we clearly see that as we gather more real-world data and update the simulator parameters with our method to better match the real world, the policy becomes more successful upon transferring. We also demonstrate our method on a cabinet sliding task where we update parameters such as the cabinet sliding friction and the appearance of the seam. Once again, we see that as we iteratively auto-tune the simulator parameters to better match the real world, we're able to learn a policy more robust to transfer. For further experiments and results, please refer to our paper. Thank you.